Alright, today we're going to be using the Pythagorean Theorem to find a missing side of a right triangle. Now, you guys have learned about triangles. We have different types. Our main focus today is going to be a right triangle. And a right triangle is just a triangle that has a 90-degree angle. So it usually looks like this, and you know that it is a right triangle when they draw that little corner, little box here. And that shows that we have two perpendicular segments. Okay, and those two lines that make that perpendicular or 90-degree angle are called the legs of the triangle. The diagonal piece that joins those two legs, we call that the hypotenuse. Okay, so our legs we are always going to call A and B, and our hypotenuse will always be C. Hypotenuse is always going to be the longest piece of your triangle. And I like to think of the leg that is labeled A to be the shortest one. But it really doesn't matter whether A and B are interchanged. You're still going to have two legs. Our formula for Pythagorean theorem is a squared plus b squared is equal to c squared. We can also reverse that and call it c squared is equal to a squared plus b squared. And we're going to be using this in our next video. But for today, we're going to be focusing our attention on this setup. Okay? Now, you will need a calculator today. It doesn't matter what type of calculator you have as long as it has this button here. We are going to be squaring a lot today or multiplying by itself. And we're also going to be taking square roots, so we need the radical symbol right above. So in order for me to access this button here, I have to hit the second button in order for me to activate that radical sign, or the house, okay? So we're going to be using both of those today. All right, let's get started. So our first example is find the missing side of the triangle, and we're going to round our answer to the nearest tenth if necessary. Okay, if we don't need it, then we don't do it. So it's really nice for us to label our sides so we know what's what. Okay, now remember the two legs are going to always be A and B, and the hypotenuse is always going to be C, the longest piece, the diagonal. So I know my diagonal is right here, so I'm going to label that C right off the bat. Now, it looks like this piece is much shorter than this one, so I'm going to give this one the label of A, and I'm going to give this one the label of B, okay? Now we're going to use our formula, so I'm going to rewrite my formula down. A squared plus B squared is equal to C squared. And we're going to write down all of these values in the right spots. So for A, I have 5. So I'm going to say 5 squared plus b squared, which is just x. So I'm going to say x to the second power is equal to c squared, and c is 13. So 13 squared, okay? With your calculator, in order to access 5 squared, you're going to press on the number 5. And then you're going to press on the button that says x squared, hit enter, and you will get 25. In other words, it's 5 times itself 5, and that gives you 25. Okay? You're going to do the same thing for 13 squared, so go ahead and put that into your calculator. I didn't have to do it for x squared because I don't know what x is. 13 times 13 is 169. If you don't believe me, you can verify it. 13 squared is 169. Okay. Now, it looks like my x squared is not alone, so this is not alone. So I'm going to use my equation skills, and I'm going to move things around so that we isolate x squared. And the way to do that is, if I'm adding 25 to x squared right now, in order to get rid of it, we're going to subtract 25. To both sides of our equation. Now I'm left with x squared is equal to, we're going to subtract, and we're going to get 144. Now here, this does not mean divide by 2. This is asking what number times itself is going to give us 144. So we have to undo the power of 2. And in order to undo it, we will take the square root of it. So we're going to take the square root of both sides. Remember, the square root sign is not a division symbol. It's asking what number times itself is going to give us 144. So on your calculator, for this particular model, you're going to hit second, then the x squared button, because now you're going to get your radical. And now you're going to type in the 144. And when you hit enter, it will give you your answer. So for us, it is 12. So x is equal to 12. And that's what we were looking for there. Okay? All right. So let's try a second one. Remember, you're going at your own pace, so please pause the video whenever you need to so that you can work out the problem on your own, and then you can check your results and your work with me. In this case, again, label your sides. Your diagonal is always going to be C, and then your legs A and B. The shortest one is A, the medium one is B. So for me, I know diagonal. This is going to be C. This looks like the shortest side compared to that. So this is going to be A, and this will be B. All right, let's set it up. I have A squared plus B squared is equal to C squared. A for me is the square root of 10. So I'm going to write in the square root of 10. I'm going to put that in parentheses to the second power. Plus B squared, which is 9 squared. And then C squared is X, so X squared. Now, you can do this on your calculator or you can do this on your own. What this is saying, we want to see the square root of 10 2 times. So this is the same as me saying the square root of 10 times the square root of 10, which turns out to be the square root of 100. And what is the square root of 100? If you do it on your calculator, you're going to end up getting 10, or you know that 10 times 10 is 100. So the square root of 10 to the second power is going to just be 10. 9 squared, use your calculator, you're going to get 81, and now I get is equal to x squared. Now we're going to add these two together. In this case, we don't have to subtract because my x squared is already isolated. So all I have to do is combine what I have on the left. This turns into a 91, but I still have to take the square root of x squared in order for us to get the value of x. So with your calculator, I want the square root of 91, so second for the radical, 91, and I get this hot mess. Now remember, we want to round to the nearest tenth, which means we want this number. We always look to the right to let us know whether we stay or we move 1. So it's a 3, that means we keep that 5. So that's going to be x is equal to 9.5. All right, we're going to try another one. Same type of stuff. We're finding the missing side of the triangle. C is our hypotenuse, A and B are the sides. We want to round our nearest to the nearest tenth. So they tell me this is B and they tell me this is C. If you need to draw a picture, okay, if it helps. Okay, you know this is A, you know this is B, you know this is C, and then put the numbers in. Okay, so I know B is going to be 7.4, C is 13.9, and we don't have this one, so I'm going to put an X there. Okay, and now we're going to use our formula. A squared plus B squared is equal to C squared, and we're going to plug these in. I got X squared plus 7.4 squared is equal to 13.9 squared. Okay, so pause the video if you need to do those calculations on your calculator, and we'll reconvene in a little bit. All right? So x squared, we're not going to do anything to it, but 7.4 squared should give you 54.76, and 13.9 should give you 193.21. From here, my x squared is not isolated, so I need to solve for x squared. That means we're going to take away 54.76 to both sides. And make sure to line up your decimals. If you do not line up your decimals, then you're going to subtract incorrectly. All right, I'm left with x squared is equal to 138.45. And we want to take the square root of both sides. Remember, that symbol does not mean division. It means what number times itself will give us 138.45. So with our calculator, we're going to take second and then 138.45. Take the square root, and we're going to round to the nearest tenth again. So the tenths place is the 7. So I'm going to look to its neighbor on the right. Remember, 0 to 4 stays the same. 5 through 9, we add 1. So because this is a 6, we've got to bump this 7 into an 8. So this turns into an 11.8. So my missing side is 11.8 miles. Okay. All right. Let's try a few more. Okay, in this particular problem, we have to state if the triangle is a right triangle, okay? Now, the way that happens is that when we use the Pythagorean theorem, whatever's on the left has to equal whatever's on the right of that formula. If it doesn't, then we know we don't have a right triangle, okay? So, you know that the formula we're going to be using is our a squared plus b squared is equal to c squared. So, all we have to do is put these numbers in the right spots and then evaluate. Okay, so I know this is going to be A, this is B, and this will be C. So for A, I have 5 squared plus B squared, which is the square root of 55 to the second power, is equal to C squared, which is 8 squared. If you need to pause the video to solve it on your own, please do that. 5 squared for us is 25. And the square root of 55 to the second power, if I do it on my calculator, remember the square root and the squared cancel each other out. So I'm just left with a 55 here. And 8 squared is 64. Now I add what's on the left. 25 plus 55 is going to give me 80. And on the right I have 64. So the question is, are these the same? And the answer is no, they're not equal to each other. Therefore, this triangle is not a right triangle. Okay, so we have to make that statement. This triangle is not a right triangle. And it is not a right triangle because when we plugged in the values for its sides, we did not get an equal or a true statement. All right, try the last one on your own. State if the 3 sides of this triangle form a right triangle. Same idea. They're already in order for you, so this is A, this is B, and this is C. Pause the video, solve it on your own, and then when you're ready, go on ahead and unpause. All right, so my formula, A squared plus B squared is equal to C squared, and we're going to write these numbers in the same order. So 37.5 to the second power plus 50 to the second power is equal to 62.5 to the second power. When I use my calculator for this particular problem, for 37.5 squared, I'm going to get 1406.25 plus 2500 is equal to 3906.25. Now I'm going to add these two together. When I add that together, I'm going to get 3906.25. And on the right side, I have 3906.25. So the question is, are they equal? And in this case, yes, they are. So what does that tell us? That tells us that the sides of these 3 sides, the lengths of these 3 sides are making a right triangle. Okay? So this is a right triangle. Well, I hope you learned a little bit more about the Pythagorean Theorem. Until next time.